Okay, welcome good people. Molweni. Namhlanje sabe senza genetics. Phawu genetics it's a monohybrid esawuqala ngayo. Now xa uthele monohybrid le nto ufuna siqale siyazile kuba yintoni monohybrid. Mono phakula monohybrid it means one, right? Single, one. So monohybrid cross it is a genetic cross between parents that have different alleles for a single gene or one gene. That is what that is the meaning of a monohybrid cross. Now let's look at an example for monohybrid cross. Monohybrid cross xa uyenza ungayenza ngendlela eziyi-two. You can use a genetic diagram or you can use a punnett square. So now let's start with a genetic diagram. Now example sayithatha apha, let's take this one. This is a cross between a pure breeding pea plant. How see it's a pure breeding or pure breed, man, pure breed. Pure breed, it means that in alleles zakho phaya they will be the same, they will be homozygous. So now sithi apha sine pea plant ezoba yi pure breed for icolor engubani engu-purple, meaning that okay, so sebenza letter P for purple, meaning that your alleles will be the same. Xa zifana phaya sithi zi-homozygous. We're saying these are homozygous alleles. So homozygous yafana capital letter P. So if this color yethu sithetha ngayo phaya ngu-purple, let's say sithi ibi recessive, masithi recessive, not dominant. This is dominant. Masithi recessive. I don't know how to write that recessive. It's fine. So let's say it's recessive. Now if it's recessive, it means that the letters or your alleles, they'll be used in small letters. So now if we're saying it's recessive, it's going to be small letter P. Unlike here, this is dominant, capital letter P. So now let's go to this genetic diagram. Genetic diagram. Now we're saying it's a cross between a purple flower. Okay. This is your phenotype. The phenotype here so it is a purple flower. That is crossed with white flower. Okay. Now your white flower, please. Now let's say in this case, your purple flower, let's say it's dominant. This one, if we're saying it's dominant, and remember, it has a pure breed. Let's say this one is dominant. Purple is dominant over white. Or white is going to be recessive. Meaning that this one will have small letters and this one will have capital letters. Both of these plants, they are pure breeds, meaning that your white is going to be small letter P, and your purple is going to be capital letter P. Now this is how you draw, or this is how you do a genetic diagram. Genetic diagram ubano no phenotype wako, ubhale phenotype yakho, nasi phenotype yakho, purple flower and white flower. Now the second one elandelayo is going to be genotype. Zithini genes zezi plants zethu phaya eza flowers zethu. Sithe lo dominant is going to be capital letter P, crossed with small letter P. Small letter P is for white and capital letter P is for purple. After you have your genotype, you move to what we call meiosis. When's it meiosis? So here we have meiosis. Meiosis what? This is how you do a meiosis. That is your meiosis. Oh, this is why we don't put arrows, we just leave it like that. After we have meiosis, we're going to get what we call gametes. We have gametes here. The gamete zethu is going to be capital letter P, capital letter P, small letter P, small letter P, and then just put a circle around them. Put a circle like that. If you don't want to use a circle, you can just put a dot or a comma. It's fine. After we have gametes, we're gonna have gonna have fertilization. That's what is going to occur. Once a fertilization, we have fertilization. Okay, we have fertilization here. Yes. Now, okay, yes, it's fertilization. This P is going to be crossed with the first small letter P, and then we're gonna get capital letter P, small letter P. All of these offsprings will be the same because the gametes of these parents are the same. They are homozygous. This is homozygous dominant, homozygous recessive. So all the offsprings will be the same. It's going to be capital letter P, small letter P. For example, this P will be crossed with the second small letter P. Still, the offspring is the same. This one to this one, the offsprings are the same. All of them will be the same. Capital letter P, small letter P. Yes. So now we say this is your F1. This is your F1 generation. F1 generation. Now F1 generation, this is a genotype. So we say it's F1 genotype. This is your F1 genotype. These ones. These are your offsprings. Now after you have your genotype, you're gonna have your phenotype. Phenotype for this F1 generation. Now we have phenotype of the offsprings. Phenotype. Okay. Now this is your phenotype. If phenotype, what is the color of this offspring? This offspring is purple. They are all purple. It's all purple. Why is it purple? It's because capital letter P is dominant, small letter P is dominant. That means the flower is color white, but these plants, they carry the color of white, but now it's a recessive. Purple only, so all the offsprings are purple. This is how you do a genetic diagram. See, this is why genetic diagram. Now, let's say if the question was saying use a punnett square to show this cross between purple flower and white flower using a punnett square. Now this is how you do a punnett square. Let's do a punnett square. Okay, yes. Now just leave it like this. We have our parents, purple parent and white parent. And this white parent is recessive and this one is dominant. Okay, now this is how you draw a punnett square. A punnett square for monohybrid, you just draw it's 4 lines that are vertical and 4 lines that are horizontal. This is how you draw it, punnett square. 1, this is your first line, so that you won't be wrong or you won't have a dirty work. This is your second line, that's your third line, that's your fourth line. These are vertical lines, that was in 4. Now let's put the horizontal lines. 1, this is 2, this is 3. Oh my god, 3, 2, 3, and that's your 4. Okay, this is how you draw it, punnett square. You put 4 horizontal lines and 4 vertical lines. You'll never be wrong when you are doing a monohybrid. This is a monohybrid cross. Now here we no longer put the symbols. You can just write gametes so that you won't be wrong. These are symbols. This symbol, this one is for a female and this one is for a male. The better way is to write gamete, because once you misplace these symbols in a wrong way, you're gonna be wrong. Your punnett square is going to be wrong. So now you better write gametes. So now it's tiny gametes Z. So now the gametes Z. It's no capital letter P. And your capital letter P. This P is this one, and this one is this one. Then now we have for white, small letter P and small letter P. Now we're not doing a punnett square. You simply say this P is crossed with this P, small letter P, and then you get capital letter P, small letter P. this one to this one, capital letter P, small letter p. And this one to this one, you get offspring, capital letter P, small letter p. And this second, capital letter P to small letter p, you get capital letter P, small letter p. Now your offsprings are still the same. Even the phenotype is the same. It's going to be purple. They are all purple because we have capital letter P, capital letter P, capital letter P, capital letter P. This is what we call a punnett square for a monohybrid cross. Yes, I'm done. I can do the second example for the last one. Let's say I'm going to use a punnett square again. Let's say we're crossing. Let's say we're crossing a black cow. Crossed with a white bull. Now let's let black to be dominant over white. Once you mix black and white, you're gonna get black only. So now let's look at the genotype of these parents. What is our genotype? Black cow yethu. We say black would dominant over white, meaning that your cow will have capital letters, capital letter B, and white is going to be small letter b, small letter b. And then now we are saying we're going to use a punnett square. 1, 2, 3, 4. 1, 2, 3, 4. You'll never be wrong if you do it like this. And then now here we're gonna have our gametes. And then we're gonna put our genes here. Capital letter B, capital letter B, small letter b, small letter b. And the offsprings will be black, all of them. They will be black. They will be black, all of them. They will be black. That is how you do it. So now, if you are talking about a genotype here, it's going to be capital letter B, small letter b, genotype F1, and then phenotype all black, but they carry the gene for white color. That's all. Monohybrid. So we're still alive. Bye bye.